All right, we have a question here that says question 8.2. That says determine dy dx if y equal to 5x squared plus 5x plus 2. Now, I'm going to write here 8.2. So we need to determine dy dx. Okay. Y is given by 5x squared plus 5x plus 2. Okay. And then to find dy, you know, the property says, so if y equal to ax to the power of n, I'll write like this. Okay, dy dx will be a times n times x to the power of n minus 1. Okay, so now, and if y equal to u plus v, okay, assuming that if u and v are functions, so dy dx is just like u prime plus v prime. So in this situation, because y equal to 5x squared plus 5x plus 2, dy dx will be 5x squared derivative plus 5x derivative plus 2 derivative. Okay, so this will be then 5 times 2 times x to the power of 2 minus 1, okay, plus 5x, assume that the exponent is 1, so this is like 5 times 1 times x to the power of 1 minus 1, and then the derivative of a constant, okay, is just 0. So if y equal to a is a constant, dy dx is just 0. So plus 0. Now we can simplify now. This is just 10x, because to the power of 1 is 1. We don't need to write the exponent to the power of 1. And then plus 5. X to the power of 0 is just 1. So we have like 5 times 1 times 1, which is just 5. Now that was 8.2.1. Now we're going to do 8.2.2. I'm going to move this. 8.2.2 is given by dx equal dx of cube root of x squared minus half x. Okay, this is like, it's just another way of solving, of writing the derivative, the same thing. Okay, so we need to find dx of the cube root of x squared minus half x. So we need to find this. Okay, note that what is inside here is f of x. Inside here is the function. Okay, and now all enclosed in the square brackets, and then the x in front of it means the differentiate. It simply means differentiate the function that we see inside the square bracket with respect to x. With respect to this x here. Now, this is what we are going to do. First, the best way is to transform the function. Sometimes the functions are not written in an easier way for us to solve it. So we're going to transform the function to make it easier for us to differentiate. So cube root of x squared here, we can change it, because the law of exponents says this. If we have like the nth root of a to the m, this is equivalent to say a to the m over n, okay? So we can write, over here, we can write it like x to the power of 2 over 3. You can write it like that, okay? And then minus a half x, okay? So to differentiate this, we will just do work out the derivative of x to the power of 2 over 3 derivative, minus a half x derivative. So this is over here we will do applying that property of derivative. So meaning we're going to move the exponent down and then times it with the coefficient and then x to the power of n minus 1. So this is what we're going to do here. This will be 2 over 3 times x to the power of 2 over 3 minus 1. Okay, that's the derivative property. In case, let me write it over here. A x to the power of n derivative is equal to a times n times x to the n minus 1. So this will be that, and then minus a half, so times 1 times x to the power of 1 minus 1, because here the exponent is just 1. And then this will be 2 over 3 x, 2 over 3 minus 1 is equivalent to, say, negative 1 over 3, okay, minus a half x to the power of 0, which is just 1, okay, a half times 1. Now this will be 2 over 3. X to the negative a third. We can work it out by using this law. That says a to the negative m is the same as 1 over a to the m. So we can work out this is like 1 over x to the 1 over 3 minus a half. So this is like 2 over 3. 2 over 3 times 1 over cube root of x to the power of 1, okay, minus a half. So finally, we can say it is equal to 2 over, if we look it up, it is 2 over the cube root of x minus a half. That's the final answer. Okay, thank you.